This question is asking us which of the following is true about the small signal model for a reversed biased diode. So that's what we're going to be looking at in the notes linked below the like button. We have our reverse bias Zener diode model. We're told that the small signal model is valid for reversed bias currents, and this is going to be the same as part B. The only thing that changes is voltages, so currents and voltages. And the same thing for here, currents and voltages. This small signal model is valid for reverse bias currents, which are greater than the knee current, which is LZK. Well, small signal model for reverse bias currents, it's going up like this. And the knee current, which would be like this right here, it's going to be less than our small signal model for the reverse bias currents. It's going upwards. And so these are both going to be true, and that's for the current and the voltage. Next we have the reversed bias, the reverse diode voltage equals the battery voltage plus the current times the incremental resistance. So what this is saying is that the reverse diode voltage, so our VZ, and we'll just write this out, reverse diode voltage, VZ, is equal to the battery voltage. So that's what we have here, so we'll do VZ0, or not, the battery voltage, plus the current times the incremental resistance. So that's this next part right here. So our current is going to be the IZ, the current of the diode, and the resistance of it here, so RZ. And that is what we have right here, it's this equation. So it works well, and this also is true. Next we have the incremental resistance of the diode can be measured from the slope of the diode IV curve. So the important part here is incremental resistance of the diode and the slope. So our slope here is 1 over RZ, which is the incremental resistance. So this is also true. Therefore, the answer to this problem is that all of these are going to be true, and that's how we would look at this material.